Day 8 of me solving an algorithm per day, and today's algorithm is bill division. Today, two friends, Anna and Brian, are deciding how to split the bill at the dinner. Each will only pay for the items they consume. Brian gets the check and calculates Anna's portion. He must determine if his calculation is correct. For example, assume that Bill has the following prices: 2, 4, and 6. Anna declines to eat item K. Bill 2, 0, 1, 2. Okay. Which costs 6. If Brian calculates the bill correctly, Anna will pay 2 plus 4 divided by 2. If he includes the cost of bills 2, he will calculate that divided by 2. In the second case, he should refund 3 to Anna and complete the bon appetit function in the editor below. Bill is an array of integers representing the cost of each item, K an integer representing the zero-based index of the item Anna doesn't eat, so it's just 1, and B the amount of money that Anna contributed to the bill. Okay, how much she contributed to the bill, and that means, I thought we were calculating it. The third line contains an integer B, the amount of money that Brian charged Anna for her share of the bill. Shouldn't we return bill? So then, bon appetit. Okay, is that the print statement we should do? Anna did eat item bill 1, but she shared the rest of the items with Brian. The total cost of the shared items is 14, and split in half the cost per person be actual 7, because B actual be charged. We print bon appetit in new line. What do we, okay, so we are basically calculating and checking if it's equal the actual charge from Anna. Did not overcharge, bon appetit on a new line, otherwise print the difference. Oh, I see. Okay. So then we can just make the difference and see if it's 0 or not. Okay. I think I got it. Let's see. We want to filter K. Is always K gonna be... K is given, right? K is always gonna be something. Yeah. So we can always say basically both sum is bill filter. I don't think we can use filter because it's the index. So what we want to do is we want to say bill reduce starting at 0, and then we can say that's actually this way around. We can say the result should be plus the next item, so we have the total sum, so to say. The total sum and then basically shared sum should be total sum minus bill at the index of K. Now shared sum, and then we should say Anna's charge is going to be shared sum divided by 2. And now if and then we can say actual charge charge is Anna's charge minus B, because that's what she gave and this is what she should have given. If she gave too much, we are in minus. If she gave exactly the amount she should have, we're at 0. If charge smaller than 0, we want to we're printing the difference, right? Print the difference. B charge minus, okay, we're just printing print charge. Else, I don't think she undercharges ever. We can say we can do an else if, or we can just say bon appetit. Correct? Is it with double P? Bon appetit. Let's run this code. Compilation error, shared sum. Shared sum declared here, let shared sum unidentified. Shared some lowercase. Okay, that test case worked. That one didn't. Your output, okay, the difference. God damn it. So that means if charge is smaller than, we can just say charge times -1. So we see the difference in positive numbers. All right, that worked out. Now the other test cases. Welcome to the finish line of this algorithm. That was a quick one. I mean, it's supposed to be easy. Sometimes it takes longer, sometimes it's shorter. Thank you for watching. That was today's algorithm. You can hit like if you like this kind of format. You can leave a feedback in the comment section if you have something to share, and you can subscribe if you don't want to miss out tomorrow's algorithm challenge. See you then.